Good morning, guys. Chapter 2. I explain the first part of chapter 2 today, magnetic effect of an electric current. I mean, when current passes through wire, any current passes through wire, this current has magnetic field around the wire. I mean, electric current inside the wire equal magnet, in meaning has magnetic field like magnet, okay? This magnetic field represents by lines around the wire, okay? These lines is called magnetic flask lines or phi m or phi m. The number of magnetic flask lines passing normally through unit area, this is called magnetic flask density. Magnetic flask density in the number of magnetic flask lines or magnetic flask lines اللي هي lines that represent the magnetic field fall normally on unit area or on area. I mean magnetic flask density المينينج بتاعها it is number of magnetic flask lines passing normally through unit area. المagnetic flask density السامبل بتاعتها B هي equal phi m over A, magnetic flask lines over area. This law is called Ampere's circuital law, or when I need to know the units of each part in this law, the magnetic flask density or B الunits بتاعتها تسلا and phi m Weber. So Tesla equal Weber per meter square عشان الاريا meter square. This is equivalent unit. Tesla equal Weber per meter square from the law. Phi m equal B time A. This law when magnetic flask lines fall perpendicular on area. But when these magnetic flask lines may fall by angle with area, make angle theta with the area, so this law becomes phi m equal B A sine theta. Sine theta, because when phi m fall with angle theta, I can resolve this vector on x-axis and on y-axis. Y-axis sine phi and on x-axis cosine phi or cosine theta, theta. Sine theta or cosine theta. This information talk in secondary one when I need resolution to any angle between the vector and the x-axis, we can put in x-axis cosine theta and in y-axis sine theta. And here I take phi m perpendicular, so phi m sine theta. I take phi m اللي هي sine theta perpendicular on the area sine theta. So the law become phi m equal B A sine theta. Magnetic field change in this in shape of lines according to the conductor. يعني المagnetic field يا أولاد in straight wire الشيب بتاعها غير لما الكرنت passes through solenoid غير لما الكرنت passes through circular coil. Okay, at first I study magnetic field due to current in straight wire. In straight wire, when current pass through straight wire, the magnetic field has properties or magnetic flask lines has certain shape. At first هما concentric circles around the wire. Concentric circles, I mean circles has the same center. Okay, circles have the same center. Have the same center. These circles closer together near the wire and farther apart from each other as the distance from the wire increase. كل ما distance increase circles دي تبقى far from each other. Magnetic field دي increase when the current increase. At strong current circles هتبقى magnetic field increase, so circles crowded. But in in case of lower current, current low, يبقى magnetic field decrease, so circles around أو magnetic flusk lines around the wire is low or a few numbers of phi m. If I have a point, I'm sorry, oops. If I have a point beside this wire and I need to calculate the magnetic flux density at this point, I have point closed from the wire or near from the wire, and I want to calculate B at this point or magnetic flux density at this point. I can determine the magnetic flux density at this point by using this formula: B equal mu I over 2 by D. Mu is the permeability, magnetic permeability of medium. This is constant for air only. Mu for air equal 4 pi times 10 of power negative 7. If the wire in the air, يبقى I use the mu 4 pi times 10 of power negative 7 Weber per ampere meter. This is unit of permeability. Comes from this law. Okay? And I current passing through the wire. 2 pi numbers will D the distance between the point اللي أنا calculate عندها magnetic flux density and the wire. This D. Okay? So when I need to calculate magnetic flux density, I use this law. For example, an electric current passing in vertical wire. This makes neutral point with a magnetic field, the magnetic field of the earth at 5 centimeters from it. 5 centimeters from it, the distance. 5 centimeters, the distance between the point والwire. Distance 5 centimeter. To turn meter يبقى أعملها times 10 of power negative 2 meter. Okay? Calculate the intensity of the electric current. I need electric current intensity. Given that the horizontal component of the earth is كذا. Tesla I mean B, unit of Tesla. B اليونت بتاعتها تسلا. يبقى هقول ده straight wire أو vertical wire، يبقى ال B equal mu I over 2 by D. But I need I, so I equal 2 by DB, 2 by DB multiply two terminals دول to obtain mu I. Okay? Divide mu. Substitute in this equation 2 pi numbers, 2 pi by calculator all 22 over 7 or 3.14 according given in the exam. Okay? The distance 5 times 5 times 10 of power negative 2 time el B. Okay? Time B. El B 18 times 10 of power negative 5 over الميو يا شباب for in air. This current in air ما قالش under water ولا قال حاجه، يبقى اخد البرمابيلتي of air، الميو of air اللي هي 4 باي times 10 of power negative 7 equal 45 ampere. Now I know the magnetic flux, the properties of magnetic field or the shape of the magnetic flux lines when current pass through straight wire. And I know how calculate the magnetic flux density at the point near from this wire. But now I need to know or determine the direction of magnetic field. How to determine the direction of circles. Circles rotate in this direction or in opposite direction, clockwise or anti-clockwise, by rule اسمها Ampere's right hand rule. Ampere's right hand rule to determine the direction of magnetic field. How apply this rule? By catch the wire by this method. Thumb points to current and the rest of fingers points to the direction of magnetic field. If the wire put horizontally, the same. If the current move from left to right in this direction, يبقى thumb points to the direction of current, and the rest of fingers determine the direction of magnetic field. Okay? If you put your hand on paper like this hand, so the magnetic field comes from here and enter here. So come out from here. Okay? Come out from here. Represent a point, the current come out and enter in the other side, enter cross, cut from the paper, cross to enter to the paper. يبقى ده out from the page with the into the page. In this case, the magnetic field come in this direction, rotate in this direction, come out from here, out from page, and in this into the page in this direction. Okay? If I have two wires, not one wire only, two parallel wires, each one carry current, how can I determine the direction and the magnitude of magnetic field? If the current inside two wires in the same direction الcurrent, okay, so applied Ampere's right hand rule in each wire. In this wire, the magnetic field come out from here and get inside the page in here, and in the other wire, the magnetic field come out from this direction and get into the page in this side. So between the two parallel wires, I have two direction of magnetic field into the page ومagnetic field out from the page. So المagnetic field هنا يا شباب inversely في الدايركشن، عكس بعض. يعني معنى كده ان انا بعمل كالكيوليت، انا عايزه اعمل، لو انا عندي بوينت هنا وعايزه اعمل كالكيوليت للبي توتال at this point، للبي توتال I mean البي توتال I mean المagnetic flask density at this point. المagnetic flask density at this point، البوينت دي between two wires. at this point أنا عندي opposite direction للمagnetic field. So I can calculate B1 from law mu I over 2 by D, and calculate B2 from law B equal mu I over 2 by D, and subtract ال B1 minus ال B2 or ال B2 minus ال B1 المagnetic flask density large minus ال small to calculate أو to determine ال B total. يبقى ال B total هنا هتبقى B1 minus B2 أو B large minus B small, because the direction of magnetic field in opposite direction. But if the point outside here, for example, so in this direction relative to first wire, المagnetic field هنا يا شباب هيبقى into the page، الدايركشن بتاعته into the page. وبالنسبة للسكند واير الدايركشن بتاعت المagnetic فيلد برضو into the page. يبقى هنا into the page وهنا into the page، يبقى هاخد دي احطها هنا. انا بتكلم على السايد ده او الفيس ده او الدايركشن ده، الناحية دي بالعربي اهو، الناحية دي. يبقى انا عندي في السايد ده كروس وكروس، هنا كروس وهنا كروس، يعني into the page و into the page. يبقى اقدر اجيب البي توتال هنا باني اجيب B1 calculate B1 by this law and calculate B2 by this law and sum B1 plus B2. اوكي، يعني نعمل summation. وفي السايد الاوت الناحيه الثانيه نفس الكلام، هنعمل summation، لان هنا عندي out from the page والواير ده هنا out from the page. فلو جبت هنا يبقى out و out، يبقى المagnetic field in the same direction او magnetic flask density in the same direction, so we can add it magnetic flask density. So أو then two parallel wires if the current passes in the same direction، يبقى in the middle هنعمل subtract للمagnetic flask B1 and B2 و out the wires هنعمل plus لل B1 plus ال B2. I can drawing the wire by this method. This point represent the direction of current and this point represent the direction of current. So current here and here come out from the page. يبقى دول same direction of current. يبقى في الاريا between them هتبقى subtract و outside هيبقى plus and plus. To determine B total at point outside I can add it B1 plus B2. طب if the current in opposite direction applied Ampere's right hand rule, so on current I1 upward اهي يبقى المagnetic flask density direction بتاعتها هتبقى out here و in here. in opposite direction هتبقى out here و in here. out from the page و into the page. يبقى ده direction of magnetic flask density. So in middle البوينت in middle عندي area في الميدل يا ولاد فيها ال B1 وال B2 in the same direction الاتنين into the page. يبقى اقدر اعمل لهم add. بس لو عندي البوينت out هنا او out هنا يبقى البوينتس وهي out انا باخد الدايركشن بتاع الكرنت عند الواير هنا وباخد الدايركشن بتاع الكرنت عند الواير هنا. فهلاقي ان هنا عندي out وهنا in. out وin اما اخد الان دي هنا هتبقى هنا out وin. فout وin يعني ده opposite direction للمagnetic field. فيبقى اعمل ماينس. يبقى في الميدل هنعمل بلس واوت هنعمل ماينس. بعمل بلس depend on E وماينس depend on E. بعمل بلس لو عندي الدايركشن اوف magnetic field same وبعمل ماينس لو الدايركشن اوف magnetic field magnetic flask density in opposite direction. لما ممكن اعمل التو وايرز دول drawing بالشكل ده فيبقى عندي هنا بوينت يبقى معناها ان الكرنت هنا go out from the page واعمل هنا cross معناها ان الكرنت into the page. فالكرنت في الopposite direction I mean الكرنت هنا in opposite direction I mean plus في الاريا between وماينس out from the wires. Then we detect the calculate BT or total magnetic flask density according the direction of magnetic flask density of each wire. لو الاريا اللي انا بتكلم عنها المagnetic flask density فيها in same direction بعمل plus in opposite direction بعمل minus. Thanks and goodbye.